we've seen the slide already, you have the index and you have the radicand. The radical is part of the index, by the way. But if that radicand had an exponent of, let's say, b, then what this allows us to do is to write this with the base x, but then we have a fractional exponent, specifically b over n. Okay, so the index for the radical becomes the denominator. The exponent for the radicand becomes the numerator of that exponent. So this is the first time we're seeing this division of the exponents. If by chance this ended up being some kind of fractional value that could be simplified, then we would. If it can't, then we won't, and that's fine too. It goes both ways. So sometimes what they'll do is they'll start with the radical and say, change it, please, into an exponent. Sometimes they'll start with the exponent, and then they'll say, please change this to a radical. Usually it works out better to change the radical to an exponent because it's easier to simplify from here sometimes, I guess. And if you can simplify this, then you can rewrite it back as a radical, sometimes with a lower index, which then makes the simplification of the original problem a little bit easier sometimes. Some examples for us. The numerator, like we just saw, the numerator of the fraction is in the exponent. The numerator is the power that's already there, like right here, right? You got, that's j to the power of 3, so it's j to the power of 3 over, and some students say, well, why is that a 2? Like I've talked about before, the denominator is a 2 there because the index is a phantom 2. If you don't see the index, it's automatically a phantom 2, not a 1 for radicals. Or k to the power of 23, so 23 is the numerator of that exponent, and then the 3 index is the denominator of that exponent, okay? And yeah, even if it's negative, so be it. We'll talk more about that later, but you can have a -5 exponent there, which would then be your numerator -5, and then your denominator there is 4. If, by chance, you just have a -15 like that one right there, it does have an exponent of 1, which is why you see a 1 there for your exponent, and then your denominator there is 5. Okay, and that's kind of what this is showing right here. This is, I guess it's kind of the rule, but usually what we would want to see there is some kind of letter there for an exponent of x. So it ends up being x to the power of a over n, I guess, which we saw in the last slide too. Again, this is just in an effort to show you that you can rewrite your, if you don't like to see these square roots, which most people don't, well, most people don't like to see these either, but sometimes they're easier.